Today we're going to be going over assignment number 2. In the future, what I think I want to do is make assignments that look very similar to the assignments that you are already being assigned. So if you don't know how to do them, you can come check out these videos to get a good sense of what it is that you need to do. So without further ado, here is an example for assignment number 2. So the first problem is going to be like problems 1 through 6 on assignment number 2, where you need to classify the scatter plots as having a positive, negative, or no correlation. So in these cases, like in this graph here, we notice that they are creating some sort of a line. So we'd say that they're generally going down, so therefore it's going to have a negative correlation. But these over here start kind of small on the x-axis. The x values have a low corresponding y value, whereas over here for higher values of x they have a higher corresponding y value. So it looks like there is a positive correlation. Now before we go on to the last one, I wanted to talk a little bit about strong versus weak correlation. The correlation has to do with how well the data looks like a line. For example, if I had another plot here and it just was an absolute straight line, that would have like a perfect negative correlation. So the stronger the correlation, the more it looks like a line, and the weaker the correlation, the more spread out it looks. So we could say that this first example has a stronger correlation because the points are closer together than these over here because these are more separated. And lastly, we've got this scatter plot here where if we had axis labels, we might know something about the data, about specific points, but in general we can't say that there's any correlation because it doesn't look like this is making a line anywhere. So we could say that this one has no correlation. So in problem 7 and 8, you're given a context with a table of data, which then you need to graph and determine whether it has a positive, negative, or no correlation. In this particular context, we're given a woman's shoe size with respect to her height. Or we could say we're given her height with respect to the shoe size, since the graph is already labeled by shoe size and height. So this isn't scaled, so I'm going to go ahead and do this now. One thing that's pretty common on scatter plots is you'll see a broken scale axis, like just a little hash, to show that we're not starting in the same window. Again, at another date, I'll probably go over that a little bit more. However, since I'm looking at shoe size, I know that the smallest shoe size here is 6, and it appears that the largest shoe size is 14. So I'm going from 6 to 14 in intervals of 0.5. So I'm going to actually start here at 6 and then go by intervals of 0.5, so 6, 6.57, and scale the rest of these. And the height is going to go from 64 to 73 inches, so I'm just going to label those from 64 to 73, starting about here. Each coordinate is going to give me 2 pieces of information about one woman, their shoe size and their height. So for example, over here I have 7 and 64, so I can go over here to 7 and I can go to 64 and I can plot that one. So this woman has a shoe size of 7 and a height of 64 inches. I can then go to 8.5, they have a height of 66. So I'm going to 8.5, that's 66. I'm going to plot the rest of these very quickly. The question is, does the graph have a positive, negative, or no correlation? If we just look at shoe size and height, you would think that there's probably a correlation because the taller someone is, they probably have bigger feet. That said, we might have outliers. So for example, we've got this outlier here where somebody has a 6.5 foot shoe size, but they're actually pretty tall. But the data does follow that the smaller the shoe size, the shorter the person is, where it starts to grow positively. So we could say that this has a positive correlation. Now the last problems, 9 through 16, on assignment number 2, ask you to identify the data sets as having a likely positive, negative, or no correlation. Well, what do you think the correlation would be? So for example, in our last problem, we would expect that somebody that has a larger shoe size might be a little bit taller. So what these problems are asking us to do is, can we find some sort of trend that would make sense given the two data sets? So for example, if I had a density of a city's population and pollution, and I just had a bunch of different cities and a bunch of different population densities, so that just refers to how many people live in that city per the area, and I was able to measure the pollution levels somehow, would it make sense that either a lower population would have a lower pollution and a higher density would have higher pollution? And yeah, it does. If you had a city that was more dense, you'd think there's probably more cars, more trash being produced, more vehicles, so therefore the pollution might be higher. So we could say that the correlation here would likely be that if you have a higher density, you will also have a higher pollution level, whereas if you had a lower density, you would have a low pollution level. So we could say that that would be a positive correlation. Now notice there might actually be exceptions to that. So for example, you might have a very lowly densely populated city, but maybe there's a factory that produces a bunch of air pollution. So even though it is more lowly populated, it might have a high level of pollution. Or you might have a city that's so densely populated that nobody drives and everybody uses public transportation, in which case maybe there's less pollution levels. So when we're looking at these, we're just looking, does it make sense that there might be an overall trend, and determining what that would be. If we go down to the amount of TV watched and academic achievement, it might be hard to visualize this. So why don't we go ahead and just create one of our graphs, and we can say, well, let's say we have the TV watched, and I'm just going to say in hours, and we have, say, grade levels, just as a measurement of academic achievement. Maybe we can do GPA. Then it would make sense that if you spent more time watching TV, your grades would probably be lower, which would indicate maybe a lower GPA, whereas if you didn't spend a whole lot of time watching TV and you spent more time studying, your GPA could be higher. Now notice these could range all around here if I had different values. In general, it makes sense that if you watch less TV, and you might have a higher GPA, but it would be negative because it starts higher and decreases. And lastly, we've got height and life expectancy. It doesn't really make a whole lot of sense to me. In the general population, I think that height and life expectancy don't have much of a correlation. If you're really tall, it doesn't necessarily mean you're going to live any longer or any shorter than anybody else. We can just write no correlation. All right, so we've just gone over some practice assignments for assignment number 2. So we've gone over some practice problems. If you have any questions, please reach out to me or your other Course 3 teacher and let them know via email. I hope to see you soon.